This video is going to introduce us to Newton's second law of rotation, which you will find is just the rotational analog of Newton's second law. We will explore this topic more in the lab in class. To review Newton's first law, we're already aware that if the sum of the torques on an object is equal to 0, if there is no net torque on the object, then it is not going to accelerate angularly. It is going to continue to move at a constant angular velocity as long as all of those torques add up to 0. This implies something about what happens when there is a net torque on the object, however. If there is a net torque, if the torques are not balanced out, then that means the object will experience an angular acceleration. Net torques cause angular accelerations. But is there a way that we can relate these two quantities mathematically? Is there an equation that we can use to calculate the acceleration that an object will experience, knowing the net torque acting on it? As a second quick review, let's just go over what we've learned so far in this chapter for rotational dynamics. So we've talked about translational motion. Objects have inertia, which we measure using mass. Objects can experience a net force, which will cause an acceleration. Now, there are rotational analogs to all three of those things. The rotational version of inertia is moment of inertia, I. The cause of acceleration that we just went over is going to be a net torque, sigma torque. And then objects can also experience an angular acceleration, alpha. It is a good idea to just have these analogs in your brain as we move on to Newton's second law. So hopefully this is going to be a quick review for you guys, but if we expose an object to an unbalanced force like this cart, which is experiencing 10 newtons acting on it to the right, then that is going to cause that object to accelerate in a linear manner. And we can relate that acceleration to the net force on the object if we take into account the mass. And we're all familiar with Newton's second law. Acceleration is equal to net force divided by mass. Well, it turns out there is a direct rotational analog to this. Unbalanced torques cause object to accelerate angularly. And there is an equation that we can use to calculate the angular acceleration an object will experience. But in this situation, it is not dependent on just the mass. It is dependent on the analog of mass, our moment of inertia. So we can calculate the angular acceleration of an object by taking the net torque on the object and dividing it by the moment of inertia of the object.